Okay, how's everybody today? All right. So, are there any questions? Um, so, so the quiz is coming up Monday, right? That would be October 15th, I believe. And we're going to do some review for the quiz today as well as tomorrow and Thursday. Let's see, before I start, there was a request to do a certain type of problem. So let me just give you some tips on if you have a problem like this. Okay, let's close this in. Suppose we have, let's say, one mass like this. Maybe there's another mass like this. You could have a third mass connected to it. Okay, and let's say this is M1, this is M2. M1 maybe is 10 kilograms. M2 is 20 kilograms. Let's say it's a frictionless surface. You press on it with 100 newtons. Okay, problem like this. You can toss more masses in. And let's say this is frictionless. Surface there. And you might ask the question, what is the force between the two blocks? Okay, what is the force that's exerted between the two blocks? In other words, you could be asked, what is the force that M2 exerts on M1? Or you could be asked, what is the force that M1 exerts on M2? It's the same answer. Hopefully everybody knows that. Okay? When you have two surfaces like this side presses on this side with a certain, let's say, 50 newtons. This side presses the other way with 50 newtons. It's Newton's third law. Okay. Everybody's with me on this? Third law? Okay. Now, the way you solve these problems is a general strategy for all these problems. When you do the second law, that's what we're going to... Oh, I didn't realize that. This is gone. Let's try to fix that. Let's see that time. Right projector. Okay, the last time I did this, the whole thing crashed, so. Okay. Screen off. Okay. Let's try this. People survive with this screen? Yes. Okay. Because if I reboot it, then we lose like 5 minutes just waiting for the thing to come on. Okay. Let's stick with this. So the general strategy, when we do these types of problems and things are stuck together, we could have a problem like this, or we could have a problem where there are two masses that are pulled by a string that connects them. Okay. The first thing you do is you put the masses together as a unit. You start with both masses together. This is, in general, the best place to start. The reason you do both masses together is because when you look at it, there's only one horizontal force acting on both masses together. Okay? In other words, the force between these two surfaces is not relevant to both masses together because that's internal to the system. We're only looking at forces acting we're only looking at external forces acting on the system. Okay? Is everybody with me on that? So we're going to have M1 and M2 together. So what is the mass of both of them together? Yeah, 30 kilograms. And then we have this force of 100 newtons. Okay, so now we can say F net, we'll just use the magnitudes because we know the direction. It's going to go to the right. F net is equal to the mass times the acceleration. Okay, so we know the net force. We're only going in the x. Let's just do everything in the x direction. This will be positive x direction. Okay, the net force in the x direction we have is 100 newtons equals to the mass, which is 30 kilograms times the acceleration. And so we'll end up with the acceleration is equal to 100 divided by 30, or 3.3 meters per second squared. Okay. Everybody's good on that? Now, we know both blocks are accelerating with 3.3 meters per second squared. Now we can address the question, what is the force that M1 is pressing on M2? Because now we consider M2. All right? Everybody with me on that? We know the acceleration of M2. We said is 3.3 meters per second squared. So now we want to know what is this force that M1 is pressing against M2. So now we do F net in the x direction is equal to the mass times the acceleration. But this time the mass is not the sum of the two. It's going to be just the mass of M2, which is 20 kilograms. Okay? And we said the acceleration is 3.3 meters per second squared. And we said, and then this F is the thing we're solving for. Okay? Everybody's looking at this? All right, and so you multiply them together, and we end up getting 66, or 60, well, depends how you want to round this thing. Okay, 66 newtons. Any questions about that? All right. Does that work? Okay. So the same thing would happen if you were pulling string, this sort of problem. It works very much the same way. You consider both of them together first, and then you figure out the acceleration, then you figure out the one on the end, how fast. We know it's acceleration, we solve for that, okay? And then we can get the force on this, the tension in that string that way. Questions? Okay. Yeah. Oh, it doesn't really matter. So I chose M2. You could have chosen. You could choose M1. Okay. The reason I choose M2 is because I'm lazy, and I know there's only one force acting on M2. But if you choose M1, then what you would have is you have the force 100 newtons acting this way, and then you have some unknown force acting this way, and then you'd say 100 minus F is equal to the mass, which is going to be 10 kilograms times acceleration. And then you'll end up finding that this has to equal 33, and so you end up that F is equal to 66. Okay, with this rounding issue. Okay, 67 as basically. Okay, other questions? All right, let's do a problem on momentum. We've not done any momentum problems. Okay, we'll do this together. This is from the notes from last time I didn't get a chance to do. So let's say a 9,700 kilogram car is moving at I just realized though, one thing I want to practice this week is your reading comprehension skills, because one thing I've noticed, sometimes people miss the problems because they don't read the problem correctly. So what I'm going to do a few times is I'm going to write the problem. I'm not going to actually vocalize it. And you're supposed to read it and figure it out. Okay? Is that all right with somebody? I'm going to be quiet for a couple minutes as I'm writing, and you're supposed to absorb it and see if you understood the problem just by reading it. Okay, so why don't you give this a shot? We're not going to do the clickers. We'll do a clicker question after this. But give this a shot, and then we'll do it together. Yeah. Yeah. By the way, I have put up a list of slides. So there's a folder with all these practice problems, but I put up in that list a sheet with quiz 1, quiz 2, quiz 3, quiz 4 problems, listing the problems in the practice folder that correspond with the quiz. Okay, so I'm going to go ahead and start it. If you're still working, you can finish up what you're doing. Try to get the answer before I get to the end. Okay, so this is conservation of linear momentum. The initial total momentum of an isolated system equals the final total momentum of that system. Okay, so we have initially, and I'm going to be lazy, my cars and my trucks will just be rectangles. Okay, so initially, I have a 9,700 kilogram car. It's coming in at 18 meters per second. Then I have a mass that's unknown, m. And then in the final case, I have these things stuck together. That's 9,700 kilograms with the truck attached. And it's moving with 4 meters per second. Okay. So we're going to look at, let's say this is the positive x direction. We're going to look at the momentum in the x direction. Momentum. Okay, let's first see what's going on in the initial momentum. We have 9,700 times 18. 9,700 times 18. That's momentum. Everybody's good with that? M times V is momentum. Okay. And then we have, what would the momentum of the truck be initially? 0. Okay, because it's stationary, it's not moving. So plus 0. And then now we have the final momentum. All right? And so the truck and the car are stuck together. So we have 9,700 plus m times the speed, the velocity, 4.0. Okay. Is everybody good on that? Okay, so I'm going to solve for m. So the zeros, just top that off. And then what I'll have is 9,700 m. And then I'll divide both sides by 4, and I get something like 43,650 on the left-hand side. And so I end up with m is about 33,950 kilograms. Okay. Any questions? You can do that kind of problem, not so hard? Yeah. Okay, this is something we haven't really discussed yet. We will get back to this when we do elastic and inelastic collisions. This particular example goes by the name, it has a name. It's called a perfectly inelastic inelastic collision. It's sort of like a football tackle, American football, where two people fight and they just stick together. They fall one way or the other. Okay. Now, inelastic. Okay, elastic means that we have some things that are kind of elastic, not perfectly, but elastic is a collision where it's really bouncy, right? And you don't lose any. We'll talk about kinetic energy later. That's why we're not talking about elastic yet. We don't even know what energy is. So elastic is when you don't lose any of the motion, the energy in the motion. But inelastic is when they're sticky, or the two things grab each other. Well, in this case, what happens is the fenders of the truck and the car, they get all mangled together. It's a different kind of thing. Right. Other questions? Let's go on. Let's see. Let's do. Let's do a problem with resolving forces and stuff like that. So let's make this a quicker question. So, wait. Have you? Again, I won't read it out, and you read it by yourself. So this is supposed to be horizontal, this is supposed to be vertical. And then we have, I said I was not going to talk, so. Okay, so that's the problem. And I will open up the pulley. All right, everybody have the chance to respond? Still working? Still working? Okay. I'll give you another 40 seconds. All right. If you haven't replied yet, go ahead and make your choice. Okay. And let's see what people said. All right, a lot of A's, but there's a spread throughout. Okay, so let's analyze the situation. This weight is just sitting there. And we have, let's say this is positive y. This is the positive x direction. Okay. Now I'm going to be completely lazy and try to solve this problem with as few steps as possible. Okay. So by as few steps as possible, I'm going to try to solve the problem without ever solving for T2. Because they asked for T1, I'm going to try to short circuit it and get rid of T2. How can I get rid of T2? What's one way of doing that? Yeah. Yeah, perfect. Because T2 is horizontal. If I solve for the y component, it doesn't play in the game. Okay? So I can just get rid of it. So we're going to look, because of laziness, we're going to solve for the y component. Okay, so now let's consider the forces. This has a weight, W, and sorry, it was 150 newtons. Okay. And then we have the force from the tension. Remember, it pulls away from the object like that. And so we need the y component of this force. And so now if I draw a horizontal line here, this is going to be 37 degrees as well. Okay. If you're not familiar with what I just did, that's just the usual thing. You have parallel lines. You have a line going through these alternating angles. Interior angles are the same. Okay, so I want to get this component here, so that will be T1 times the sine of 37. So everybody's good with that? It's opposite to 37 degrees. You have this right triangle. This is T1 is the hypotenuse. Okay. Any questions? Can everybody do this? Everybody's okay. All right. If you can't do this, you will have trouble with lots of problems. So make sure you can do this. All right. So because T2, as I said, is just in the horizontal direction, I don't need to consider that. So now in the y component, we have to have the net force. Y component is equal to 0. And so we have this guy. That's the y component of T1. So we'll have T1 sine of 37 degrees with a plus sign because it goes up. And then we have this weight going down. So 150 newtons equals 0. So we can just solve for T1 is equal to 150 newtons divided by the sine of 37. Plug that into your calculator and get 249 newtons. All right? Questions about this? Yeah. Say it again? Oh, because it's not moving. It's in equilibrium. There's no acceleration. It's suspended there. Questions? You had a question about, yeah. Yeah. Okay, so the question was about a homework problem kind of like this. Oops. Uh, uh, okay, so we have this is attached to some. I guess you can think of this box as a worker, which is kind of weird, but okay. And do you remember this homework problem? Okay, so the worker, which is drawn as a box. I don't know why I drew it as a box. Okay. Anyways, that's his arm, and he's pulling on this. You remember this problem? Okay. And you want to know how hard the worker has to pull it. You remember this problem? So, okay, the way to analyze it is, okay, so there's some tension here in the string. It's a massless string, there's no friction and all this stuff. So all you have to do is you have to just consider how many support strings that are holding this guy up. Okay. There are 3 strings that will be pulling up on the person. Okay? So the point is, this is another point of contact. This is another point of contact. So basically, if I cut these wires, right, I'm cutting the tensions of 3 different forces. And they're all holding this guy up with the same force. So 3T is the total. So if you want, I can think of this as a box and consider what are all the forces pulling up on this little box surrounding the person. Okay. It's 3T. And so that must be equal to the weight of the whole apparatus, this little pulley plus the worker. Okay. Questions about that? That's how these pulley things work in equilibrium when you need to have some mechanical advantage. You just figure out how many wires are supporting it. Or string. Questions? Yeah. Yeah. The thing is, I don't want to get too far into the homework. I want to go more towards the quiz. So yeah, we can discuss that afterwards. But the general point is that if you have a system like this, okay, suppose this was a stack of weights, okay, and you pull down with a tension T, and this is like in a gym or something, and this weight stack goes up, all right? The point is that it's again, you look at this weight stack, there are 2 support wires that I'm cutting with this, drawing this box. So there are 2 tensions pulling up the weight. So if I pull up with tension T, right, then the weight, what I have is 2T is equal to the weight of these blocks. That's all it is. It's the same thing. Other questions? Okay, let's go on. Let's jump around a bit, different types of problems. We had enough for the video, so let's go to okay, let's do this problem. Let me get more space here. Let's draw. Okay. Okay. That's a mega. circle, radius 0.15. And then we have a coin here. All right. Okay, so the question is, by the way, this is a turntable. Just a rotating disc. And that should give you the mass of the coin is going to be 7.0 grams. I'll write GM so you don't confuse it with G. Okay. And so here are the choices. Okay, give that a shot. Oops, didn't press it. By the way, the practice quiz 3 is posted, and I will try to videotape the solutions tonight. Oh, the mass of 7 grams. The symbol is G, but sometimes people get confused with G and 9.8, so I would go GM. Yeah. The direction? You want to know the direction? The direction? Okay, yeah, that's another question. So I didn't ask the direction, but what is the direction of the static gradient? Yeah, towards the center. Right? So if something goes around in a circle, the acceleration points, the centripetal acceleration points towards the center of the circle, okay, for uniform circular motion. And then the centripetal force is the net force required to make it go in that direction. Okay, so that's why it points to the center of the circle. Okay, people are not giving answers very quickly. Oh yeah, here's an example of a problem there. Quiz 3 problem, clearly, but it requires you to use some quiz 2 knowledge. Right? This omega thing, you have to know what to do with omega. Another example, you might have a case where you have to use some quiz 1 knowledge. For example, you get an acceleration, and you want to know how far does it go in a certain time. Right? Then you have to figure out how to do that. So now that we've reached quiz 3, the problems will be quiz 3 problems. Will be those sets of problems, but they may have some link to quiz 1 and quiz 2. So you might want to go back and if you've forgotten something basic from that. So I think it's really good to give you challenging problems that you do with clickers. The only problem is that it eats up the class time pretty significantly, so we can't cover as many. So maybe what I'll do is I will just do a couple of these, and then it will solve problems without the whole clicker thing, so that it goes a little bit. We can cover more problems. Okay, should stop it at this point. So if you haven't made a choice, go ahead and make your choice. All right. Let's see what people have said. All right, we have some A's, but other things as well. So let's take a look. Okay, first we need to know the speed of the coin. Okay, so v is equal to omega times the radius. So you just multiply by the radius to go from v and omega. Omega times r. So we have 3.5 was the radians per second, the omega, times the radius, which is 0.15, and that comes to about 0.52 something meters per second. All right, now the rest is pretty straightforward. We need a net force, what we call the centripetal force, that allows it to go in a circle with uniform speed. And that formula, what is that formula? What is that? M times A, where A, and then M, what is A? V squared over R. Okay, so mv squared over R. Okay. So now we just plug in. M is 0.007 because it's in grams. Right? Remember, grams are not the standard unit of kilograms, so it's 0.007. And then V we just calculated is 0.53 to 52. And then divide by the radius, which is 0.15 meters. And that comes out to 1.28 times 10 to the minus 2 newtons. If you round it the other way, you get 1.29. And so this net force has to be provided by static friction. It's the stickiness of the coin on the surface that provides it. Yeah. That should be already. So is that on your equation sheet or not? It was? Okay, yeah, that's on the equation sheet already. You can take a look at your equation sheet that we have for quiz 3. It's there. That's the wrong page. Okay, so let's see. Practice problems, quiz 3. Formula sheets right here. You can take a look at what we have here. Okay, V equals R omega. Okay, all right, so we only have a few minutes left, so not enough time for a quicker question. So let's just let's do a problem together. Let's see. Let's do something short. All right, let's do this one. Although I'm going to have to zoom this in. Let's just look at this together. Okay, so this problem is from test 2C. It's number 12. So let's just read it together, and I'll try to do it in 2 minutes, okay? So, a 55 kilogram student rides a Ferris wheel at the state fair. When the student is at the highest point of the ride as shown in the figure, she is 9 meters from the rotation axis, from the center of the Ferris wheel. Okay, she's sitting here. And by the way, the Ferris wheel is not, you don't go upside down on the Ferris wheel. It's one of these slower things where the seat always remains, it's for your mom and dad. Right? And so you remain upright. Okay. And so when this, you're at the highest point, she's 9 meters from the rotation axis, okay, with a tangential speed of 2.5 meters per second. So that's how fast she's going. Find the normal force from the seat on the student when the student is at this highest point. Okay. So how would we solve a problem like that? Well, this is again circular motion. We need to have a net force that is mv squared over r, just like we did. Okay. She has a speed v. There needs to be a net force that's going down. That will be mv squared over r. So if I take y to be the up direction, then the y component of the net force will be minus mv squared over r. Is everybody with me on that? It has to go down because that's the way you go to point towards the center of the circle. Now, so the net force is going to be minus mv squared over r, but now, well, okay, so we'll calculate. We'll plug in 55 for the mass, and 2.5 for the speed, which we're given, and 9 for the radius, and so we get negative 38.2 newtons. And now we figure out what are the forces. We have gravity going down with mg. Then we have the normal force of the seat pushing her up with Fn. So we have Fn minus mg. So we have Fn minus 55 is the mass. 9.8 is g. So then we have Fn minus 539. But we said that the net force must be equal to negative 382. So then we end up with Fn is equal to add 539 to negative 338.2, and you get 501 newtons. Okay? Any questions about that? I'll see you guys tomorrow. Oh, because it points down. I'm getting the y component. I'm taking up to be positive. So I'm taking into account. I'm using this as the positive.
So that's centrifugal force.
Yes.
It's pointing
Yeah,
inward.
that's the point.
We have our F net. We have the F net up, and then we have